Okay, look at that, that's pretty cool. We're going on to the next page, guys. I'm pretty sure at this stage we are not going to use any more of these 25mm long bolts, so you can set them aside. Nuts. I don't think we use any more of these either. We're going to be looking at only yellow hardware bag stuff left. And where we're going to start off with is we're going to be putting all the motors on to the machine. So this step is pretty straightforward and it's just repeated 4 different places. We're going to grab our motor box over here because, you know, we need the motors to put them on. And I just left them off to the side here. Motor box. And when you open this up, you'll find 4 of the same motor. These motors we get custom made for this machine. Not because it needs to necessarily be custom made. I'm going to take the wires out too, by the way. It's not necessarily because it needs to be custom made, but getting them custom made ensures that they get made to the quality that we need them to be made to, so that they perform well on your LongMill MK2. The other thing that is custom on here is actually the connector that we use on the motors, because a lot of the connectors that normally are used for the motors, we found that they are more finicky or more likely to become disconnected, or they don't carry enough current to reliably power the machine. And so we just went with something that was way more overboard, stayed connected permanently. You can still disconnect them, but it's just hard to accidentally disconnect them. And so that's why we've got these set up this way. So for each of these motors, basically, you're just going to sit it down on the table. And you're going to want to be grabbing from this bag of long M5 bolts, the M5 50mm. And you're also going to be grabbing from the bag of aluminum spacers. And you're going to have another bag of these washers that are white. And they're white because they're not made of steel, they're made out of nylon. The reason these plastic washers are used is twofold. A, they kind of help keep the assembly together when you're attaching the motors at different parts of the machine. But B, they also... Oh, there's still a bunch more left in there. B, they also actually help reduce vibration when you're using the machine. We found, before we introduced these washers, we found that the machine at certain speeds would have, if you have any engineering background, you might recognize this term, but a resonant frequency. And basically what that means is that the, by the way, I'm just following the instructions here. I'm putting the bolt through the one side. I know it's kind of hard to see from this perspective, but from the close-up you should be able to see it. I'm putting the bolt in from the back side, then the spacer, then the washer. Yeah, so for resonant frequencies, essentially what that can mean is depending on how the material is and the shape of it and its properties and stuff like that, certain vibrations will cause a really loud noise, basically. This is kind of how stringed instruments work. If you've played any sort of string instrument, you're giving a very light tug onto this, steel wire, usually, and it's making a really loud noise. So we were finding that happening with the machine at certain frequencies, and so we opted to use these spacers in order to basically add some dampening. The plastic kind of acts as a separator between the metal motor and the metal plates, so that you don't end up having that frequency anymore. And thus, the machine can run much quieter. And that's all we were really going for, was just that the machine could run at a more normal tone. Now, mind you, the sound of the machine isn't all the sounds that you'll hear when you're running it in practice. When you're running your machine, the loudest noise usually is the router running, or the cutting tool cutting, or your dust collection system, whether it's a vacuum or a dust collector or what have you. So I guess it's debatable whether we really needed to address the loud noise from the machine, but to be honest, it's something that is always best to address, because sometimes vibration can lead to other things. And so we wanted to make sure that the machine had all the longevity we could give to it. I'm just going and doing all of the motors at the same time, just like how it shows in the step. And we're going to use up, this step uses up all of the washers, all of the spacers, all of the M550 bolts. So if you have any left over, once you put these 4 motors together, you can just set them aside. Depending on your machine, you might find that these nylon spacers are either relatively loose, or they might be a little tight on the M550 bolts. And if they are tight, then that's fine. It's actually, it makes the assembly easier for you to put your machine together. If they're loose, then sorry, mine are loose as well. So I'm in your camp, but it'll make the putting on the motors a little bit trickier, but not too tricky. Oh yeah, by the way, this step does say, grab your cold drink, and you know, if you're taking a break or you're resuming this video another day, at the end of your first long day, sit down with a friend and be like, hey, this machine is coming together really nicely. Great, so we're just going to, the following steps show the diagrams for, basically you're going to put the motors for the y-axis on the back here. You might have to reach around your machine or something like that, and make sure the wire comes out the bottom of the motor. And then you're going to be putting the motors on the x-axis, and this one is going to come out facing up and backwards because the motor's kind of twisted 45 degrees. And then the z-axis, you're going to be putting it on, and the motor's going to face backwards as well. And when you're putting these on, basically you're just going to be making sure that the motor shaft slides into the coupler, and then all the places the motor attaches, they're tapped, so you just screw into the tapped holes. And once the motor is firmly attached, you'll then want to go and tighten the other side of the coupler, the one that I've been telling you this whole time not to touch. You can now go and touch it and tighten it. So I'm just going to start with the y-axis here. And oh my. And basically the strategy here is you just want to try to keep everything nice and level. Make slow movements. And just try not to panic, basically. The step can get, if the plastic washers are a little loose, the step can get a little bit fiddly, I would say. But really all that you need to do is you just got to get the motor in the right place first. And once you've got it in the right place, I usually go for the bottom bolts first. And I'm just going to use the long end of the Allen key to reach the bolts. I'm just going to go for the first bolt. Try to get the thread started. And then as soon as you can get the thread started on at least one of them, then it'll make it easier to go back around to the other ones and start on those, because the motor can kind of hold itself in place and you can focus on getting the other bolts threaded in. If there's a little bit of paint on the edge of the threads, you might find that they don't want to go in super easily. So just put some force against the bolt while you're turning it to try to break through that paint layer. And once you're broken through, you'll notice that the bolt starts threading on. Now, some of these bolts for me aren't going on super nicely, so what I'm going to do on the next set of holes is I'll probably just take one of the spare bolts and thread it on beforehand, just to make sure that all the threads are going through properly. And I'll do that on the plate and the Z as well. And then that'll give me a bit of a better chance at putting the motor on for those other spots. Let me just check something here. So it's almost like I planned this, but I totally didn't. But this is actually a step that we do mention in the manual, and it's a bit of an edge case because it doesn't happen very often, but I actually have a chance to show you that it does still happen. So what I've actually just noticed about my feet here is that this back foot in particular is actually missing the threading in, I think, one of the holes. I can't quite tell right now. And that's something that, you know, we check obviously when we're packing the feet up. Let's see here, how many are there? So it's actually the two bottom holes here that have somehow missed being tapped, which is a real shame because, you know, I would really hope that we would catch something like that. But this actually brings me back to earlier on when I mentioned there's some redundancy in the design. And so what I basically mean by that is that these feet, they only go on the motors only thread onto the back feet and not onto the front feet. And same for the Y gantries. They only need to thread on, the motor only goes on one side, not the other. And so in these sorts of extreme circumstances, you can always swap them. So I can swap the front feet with the back feet and then continue on. If you are the type of person that has a set of taps on hand, you can use that obviously if you'd like to. But if you don't, you know, it's not necessary. And if you have more than one foot that is causing you issues, obviously we will replace it because, you know, that's on us. So I think what I'm going to do in this particular circumstance, because I want to kind of continue this assembly on quickly, is I'm just going to probably run a tap through this foot off camera real quick, and then just continue on forward. But now you guys know that these are things that could happen during assembly, and then you can watch out for them. Okay guys, we're back. We've got the foot tapped. I did go actually, while I was tapping it, and just go check up with our quality control guy because, you know, it is just, you know, 2 holes out of 4 feet, but I prefer things to be caught rather than not caught. So we're going to just make sure that we're looking over things. This is one of the cool things of doing the assembly ourselves, and also doing a lot of the other stuff we do in-house. Just on the other side of this wall is where we do all the assembly and shipping of the machines. So I can just go over there and say, hey guys, just make sure you check out these particular things. And if we can do that to inform the process to get machines to you guys better, then of course that's what we will do. So now that I have confirmed that, you know, all of these tapped holes are set up correctly, I'm going to do what I said before, where I'm just going to start off with just one of the spare bolts here, just so that I don't have to play around as much with getting the motor in there, or the motor bolts in there. So that gives me, it makes things a little less finicky when you're actually trying to balance everything and also attach stuff. Probably isn't strictly necessary, but especially if you have the more tight-fitting nylon washers, it should be pretty easy for you if that's what you have. I've got a little metal chip here, so just from the tapping I did, you guys should be fine. The aluminum block up here, you shouldn't really need to pre-tap that because that's not actually painted, it's anodized, and so the anodization process adds very little thickness, so that one's probably fine and good to go. And the threads on here actually seem very well done, so I won't worry about that either. Okay, back to putting the motors on. Usually what I like to do is I like to kind of angle all the motors inwards. That kind of stops things from moving around. Then I can kind of stick the washers on there without having to worry. And now we keep it all level, and we come in to start the threading. That's the first one started. And my motor shaft is in the coupler now. That's the second one started. Clicked a bit further into the shaft there. That's the third one started. And the fourth one. So now you should have a pretty easy time just alternating between the 4 bolts, just like we've done many times before. Where you do the final tightening, once they're all relatively snug or relatively loosely snug, then you go in and you finish them all off. And if you want to do the final tightening, you can use the short end of the Allen key to get a little bit more leverage. And there we go. And then before you move on to the next one, you just want to go and, as I mentioned, tighten the other screw. And there's a specific angle you can kind of get in here so that you can use the short end of the Allen key, and that'll help you to tighten it down much more solidly onto the motor shaft. Just take your time with this. It's a bit of a small space, so it can be a bit finicky. But you don't want to go too quickly either, because you don't want to strip the bolt head out if the Allen key isn't sat all the way inside of the bolt. Okay, motor number 2. It's pretty crazy to see that with so few parts, you've got such a rigid and precise motion system, essentially. if you look at one of the y-axes on its own, you've basically just got a motor to a screw to a nut on the other side, and then you've got a rail in 2 feet or a rail in 4 feet, and then the plate that's driven by the screw on the V-wheels. And if it seems simple to you, it's because I worked really hard to make it that simple. There's lots of parts during the design process where it'd be really easy to use an extra, piece of machined aluminum here, or an extra, steel plate or whatever, angled brackets like 90-degree brackets. This design went through quite a few iterations because we needed to see what made sense to integrate into the geometry of rails so that they were both lightweight and strong and functional to the assembly of the machine without compromising too much in any of those areas. And that also tied into the overall design of the machine as well. Because if you, for instance, the T-slots that we use on the Y and X rail to pick up some of the other components, if we didn't have those, then you can imagine the additional complexity that could come even if the design stayed the same. Like, let's say this drag chain mount attached the exact same way, we might have to introduce an additional level of quality control with a jig and everything, just to make sure that the holes are located in the right spot and they're tapped in the right way to ensure that it goes together well on you guys' end. And the other thing to consider is that if we were to make any more unique parts than we made already, then for every unique part, we have to, obviously you have to manufacture it, but you also have to, paint it or coat it. And, we have to make space in our facility to hold that part, which adds more cost. We have to package that part so that it doesn't get scratched up or broken or whatever during transport. We also have to have a whole quality control process for that part. We have to do a lot of inspection, and the more parts there is, and the more percent of parts you could have going towards part failure. And then, it's even more added complexity for you guys during assembly, because we have to show you this new shape and tell you how this new shape integrates into your machine. And it also means more stuff could go wrong, right? If your machine is really complex, a machine like this is very dependent on a lot of its key parts. And so the more parts the machine is made out of, the easier something can go wrong. And as soon as something goes wrong, you might lose the operation of your machine, right? So, So anyway, that's a very long-winded way of saying that the designing the machine simply becomes very obvious that you want to do it that way. And I'm sure when I say that to you, it makes sense to you right away. You're like, oh yeah, obviously. Make the machine as simply and with as few parts as possible, and then there's the ticket. The problem is solved. But yeah, at the end of the day, it usually doesn't end up being quite as simple as just make it simpler. So that's why we sit around all day trying to think of every single possible way that comes to mind that we can solve a problem, even down to the general layout of the machine. So this step is definitely the hardest part. If you have the loose fitting washers, I'm going to place them on the mount rather than try to hover them on the bolts. And then I'm just going to pray that when I come in from above, and I'm just angling them in again, that I can make... Yep, that's what happens. That's what happens. Just doing it a little bit at a time here. There we go. Remember, the wire phases backwards. I think, since I got a bit distracted talking to you guys, I think I didn't actually tighten the set screws on couplers, so I'm going to go back and do those after this motor gear is attached. Okay. I definitely did this one, so I'm just going to check the other ones. Yep, I missed all the rest of them. So, don't be like me. You'll know, if you do happen to miss this step, you'll know that you did because on the next, after we finish wiring the motors up, we're going to be going and actually moving the machine around. And so you'll see when you move the machine that one of the sides won't move. And that's like one of the reasons why motion doesn't happen, basically, is that you haven't tightened down on this coupler far enough. And so the motor is moving, it's spinning, but because the coupler hasn't been tightened down on, it's not actually transferring that rotation to the lead screw. The last thing I'll say about the couplers is that if you did happen to tighten down the wrong screw, we do have written in the text of the manual a way that you can basically if you tighten the screw down before you're supposed to, it kind of closes the coupler too far, and then when you go to put the motor on, it won't go on. And so if you notice that, then that means you've accidentally tightened it down on the wrong side. And we have a step laid out there about how you can take a thin object like an X-Acto knife or a paint scraper or something like that and put it in the slot of the coupler, take the screw out and screw it in the other way and kind of spread the coupler back out again. But since we did it successfully, we don't have to worry about that. So what I'm going to move on to next is drag chains. Hooray for wire management. So, as you see in this step, you can either be unclipping these with a sharp object from the side, or you can use the taper of the wrench in order to be opening the drag chain up. It depends on what type you got. Some of them, depending on the supplier we get them from, some of them open better one way and some the other way. This type, I can tell, is better with a sharp point. So if you were one of the people that grabbed a flathead screwdriver, then at this point you could use it. I didn't grab a flathead screwdriver, so I'm just going to use the tip of this wood screw from the bag of wood screws that we provide for mounting your machine. And I'm just going to use it to click open these tabs. Now, you'll see in the text that we basically recommend that you take half of these tabs off permanently. Actually, I might use a knife for this. The reason why is because they are pretty annoying to open up. And to be honest, they aren't all necessary to hold your wires in place. In fact, most of the time we found that you only need one of these clips, or one of these clips, you only really need one every other link. And sometimes you can even get away with putting them one every third link. So consider taking them off if you're just going to do this wiring once, it doesn't really matter. But if you're going to be putting on the limit switch kit, for instance, if you ordered that from us, or if you're going to be switching out to another router or a spindle later on, or just anything associated with the wiring, then you'll want to probably remove at least every other clip, because doing this, if you think this is kind of tricky now, it becomes even a little more tricky once the chain is actually on your machine. And so you want to just reduce that scenario, or reduce the frustration of that potential scenario. So for now, I'm just going to open them, and then I'm going to remove them afterwards completely. After this step, we're going to be taking off the chain ends. Each chain has an end on either side that can be bolted down. And so those will be bolted down to the machine itself in preparation for reattaching the chain and the wires. And so if you're ahead of me, feel free to unclip the ends from the chain once you've opened up all of the clips. If you've got the 12 by 30 long mill, one of these chains will end up being quite short, and so you actually don't need to bother opening all these clips right away, because half of the chain you won't even use. Okay, so to remove them, there's just a little kind of clipping geometry on the other side. So I tend to leave the clip on that's at the end, and then start from there, removing them. So I'm going to go one every other. And if you're careful when you're removing these, they should be able to stay intact, and then you can reuse them later. But sometimes the plastic can break, so just be mindful of that. These clips, you have to kind of pull them off at the right angle for it to be easy. And if you're not taking them off at the right angle, they won't want to come off as easily. Every time I get to this stage of putting the machine together, I always think to myself how wild it is that I've taken such little amount of time to put together this whole, mechanically awesome looking machine. And then I'm now sitting here just removing little pieces of plastic. But the reason why this wiring step is very crucial is because as nice as the mechanics of the machine are, if you don't have properly functioning electronics, then you don't have a working CNC. And where drag chains come into play is that they are there to ensure that over the hundreds or thousands of cycles of movement that you make with your machine while it's going cutting out whatever cool things you're cutting out on it, that the wire doesn't get loaded in a way that it's going to bend and break with time. That's one of the reasons why the chains have a certain bend radius to them, even. It's so that they're able to kind of guide the wire along while the machine is moving, so that the wire can last just as long as the machine can. If you see any machines that don't have proper cable management, then I would be a bit, I don't know. I would warn against getting them, or if you do want to get them because they're at a good price, then I would try to set up your own wire management system so that can ensure the machine and the wires will stay around for a while. So basically when you're removing these, you're going to, we've got what we refer to as a pin type link, and the pin type is the one where the pivoting pin is built into the link, and the hole type is the one with the hole built into the link. And so for the pin type, you want to squeeze the pin type inwards while simultaneously pulling the link that's next to it outwards. And I'm just going to focus on the outside one for now because that's easiest. So I'm going to push up with the thumb on one and push down with the thumb on the other and make a twist with it, and it's going to pop out. And then we do the same on the other side except flipped, because this is a hole type. The end link you want to push up, and then the link that follows it you want to push down. And once again, I'm going to focus on the top side and just give it a bit of a twist. And if you end up in a situation like this where it kind of seems removed, but kind of not removed. Just, twist it up and turn it around, take your time with it. If you go and you rip this off, this plastic can break. And now the drag chain is all for nothing, guys? Like, just take your time. There's, I know you can see the finish line right now. So, but, don't rush on your way there. There we go. So you can see in the picture, as well as here, you've got all your end links, and you've got your prepared drag chain. And so now what we're just going to do is we're going to locate these on the machine, secure them down, and then we can reattach the chains afterwards. So we're going to take a hole type and start on the y-axis, the side that you have the drag chain mount. And every one of these attachments is going to use, or almost every one of them is going to use a T-nut, just one T-nut, and a bolt. And these are the short M5 bolts that came in the yellow bag. And so starting at this one, I'm going to slide the T-nut in from the front of the foot here. And I'm just going to bring it back to, as the instructions say, you kind of want to position it a little further back than halfway on the rail. So, if this is my whole rail, this is looking at about halfway right now, so I'm just going to slide it a little further back. The position isn't critical, but what you will notice is that when you go to make your first movements, if it looks like it's really like pulling the chain tight, instead of flowing very smoothly, then you can always reposition the links slightly in order to get the right movement from the chain. And then I'm just going to put the bolt in on the middle hole and screw that through into the T-nut. Just like that. We got the red arrows again, so we're tightening these down. Now I'm going to take the pin type, and in the yellow bag, you will notice this tiny little plastic part. You'll be able to see it better in the picture. But essentially what this does is when this mounts to the drag chain mount here, we just want to make sure the chain isn't twisting around because, it's only on one bolt here, it's only on one bolt here. So, you can twist around potentially. So this little bracket here will basically ensure that it's got some ridges on it, ensure that when you bolt it up onto the mount here that it doesn't twist around. This one doesn't need a T-nut because the mount itself is tapped. So I'm just going to start the bolt off through the link and through the bracket here. I call it the chain aligner because the little plastic piece that you're using here I call it the chain aligner because it keeps the chain aligned straight. And you'll notice that once that's on, this won't want to twist or anything. It's nicely, solidly in there. Now we're going to move on to the other pin type, and this will be used on the x-axis rail. And we're going to slot in the T-nut from the opposite side here. And then we're going to put the bolt through in the center again. And we're actually going to butt this connector, or the end link, up against the drag chain mount. And by butting it up against the drag chain mount, it's going to make sure that it doesn't twist anywhere, because the drag chain mount is firmly attached. Butt it up. Tighten it down. Now that's not going anywhere. And the final one will be up at the top. There's two tapped holes here, but you don't need to use both of them. In fact, you really only will be able to use one of them. And so just put the one bolt through, make sure the mount is relatively, or sorry, the end link is relatively straight against the back edge of the Z-axis motor mount. Okay. So this is where it gets to be kind of fun, and I think what I'm going to do is I'm actually going to move around to the front of the table, and we'll just shift the cameras a bit, because then I can be out in front, I can put on the router, I can put on the wires, and you can see it a little bit better. And so we're going to do that just now. Okay guys, so I'm at the front of the table, and we got the machine here. This will be a lot easier for me to work on, because now it's oriented the same way it is for you guys. Although you're going to see my back a little bit more, I hope that's all right. So we've reached the stage now called routing wires. And basically when we're routing the wires, we're going to need to make sure that A, our drag chains are the right length, and B, we've got all of the wiring started so that we have wires to route. So what we're going to do is for the y-axis drag chain, we're going to basically, it says in the instructions what to do for the 12 by 30, but I'll say what to do for the 30 by 30. You're going to be removing 13 links off one of the chains and then adding 3 of those links back onto the other chain. So it doesn't really matter because right now both the chains are the same. So I've just chosen this one and I'm just going to count to 13. And I'm just going to open it up. So that's my short chain now. And then I'm going to count 3. 3 on this side. Break that off. And then I'm going to reattach it onto this other chain. And when you're putting it back on, the little pins have ramps on them, so you should be able to ramp it into place. And I'm just going to set this extra piece of drag chain aside. It's not really needed anymore. And next thing I'm going to do is I'm going to grab the Makita Router Box. Now, if you don't have the Makita or you're using your other, some other setup, that's fine. You want to go grab it now and start getting it in place. So it's all taped down very snugly, so there we go. And this comes with its own manual that you can check out, as well as it comes with its own trim router base, which if you were using it as a trim router is really useful. But since we're not, it doesn't need that base. And then just make sure you go deeper in the box. You've got a bracket that you can use. This is also for trim router use, so don't worry about that. But it does have wrenches in it, and you need these wrenches in order to use the Makita router. So I'm also going to take this base off here. You just undo the lock on it. You can pull it off. And I'm going to put that back away too. We're going to put this box off to the side. So as you can see in the picture here, we're going to be sticking the router in place. I'm just undoing the twist ties here. When we put this router in, we're going to put it in a very particular angle. And the angle is important, but the height of the location of the router is less important. So this will just fit in here. And if it doesn't go in immediately, you'll just want to loosen off the screws on the front here. So that fits in like that. And essentially the angle that you're trying to hit is you're going to be getting a rotation. So the wire is going to face out to the left side and you're going to be rotating it towards the back. But essentially you want to make sure that, and I'm just going to by hand twist this coupler up all the way, is basically you want to be making sure that the body of the Makita isn't going to collide with this aluminum bracket here. When it's at the top of its motion. So obviously that's going to depend on how, I'm just going to grab this. That's going to depend on how far in the router body is, because obviously if it's higher up, it's going to more likely collide with the back Z-axis motor mount here. And if it's lower down, it still won't get anywhere close. So I'm just going to grab my Allen key here. And the position I'm just going to put it in, as I said, is this. It's just going to be, I'm just looking at it from the top, twisting it back to make sure that it still won't collide, and then just lifting it up slightly. And then we're going to tighten these two bolts on the front to secure it down. And just like all the other bolts, we're going to alternate between the two so that we're kind of evenly tightening down onto the body of the router. And now that's nicely attached. So another optional step here, which I'm not going to do just because I don't have a zip tie on hand, but you can do, is if you move this router all the way down to the bottom, this top left hole here can be used to mount with a zip tie the router wire. And that can be pretty handy because the wire, when it's moving up and down, could get in the way of other things that you're trying to do. And so it's nice to just have it mounted in a predictable location. Just make sure that you move the Z-axis all the way down before you attach the zip tie. And also when you attach the zip tie, make sure you're not zipping down really tightly on it. Otherwise, it can start to wear away at the wire itself. So all these motor wires that came with the motors are all the same length, and so you don't need to worry about choosing a particular length wire. We're just going to start off with whichever one we want and clip it into the Z-axis and just work our way back through from the Z-axis to the X to the Y. So just as shown in the picture here, you'll see it clips in place. And then we're going to want to bring in the long drag chain and check that you have it oriented correctly. You're going to have the pin on one side and the hole on the other side, and those need to line up to which connector is attached to the machine already. And then I'm just going to go in and make sure that all of these clips are opened up. And just as what's shown in the picture, you can now start to run the wiring through. And you're going to do the same with the router wire. This little ferromagnet is, you can have it on either side of the router. If you want, you can have it on this side, and that'll help to reduce noise coming straight out of the router. But it can go on the other end too. And I'm just going to not clip the first clip, but the second clip. And then clip in some of the following clips just to get everything positioned how I want it to. And then I can kind of go in here and clip in the closest clip as well as bring it into place on the end link here. Now don't worry about how much slack you've got of these wires. You can always go in later and kind of shuffle it along as you work your way through the drag chain. What I've got here right now is fine. So if you do plan on adding anything else to your machine immediately after you're done this assembly, don't close these links like I am, because things like the limit switches, you're going to want to run through these links or through the drag chain, and so it's going to be a bit more of a fun time, let's say. And then I'm not going to close this last clip. I'm going to slide it onto the connector first, and then I'm going to close the clip. And the reason why I'm closing it afterwards is because it gives, if it's closed, it gives the chain less flexibility to clip into itself. So I leave the clip open so that it has that extra flexibility. Great. So now we're going to grab a second wire and attach this to the x-axis motor. And while you're doing this, feel free to add labels to your wires. It can make it easier when you're attaching these wires onto your control box. And once again, we're just going to make sure we have everything facing the right way. We're going to feed the wires in. This time we're feeding in the Z-axis motor wire, which is coming from here, and the router wire, which is also coming from here. But we're also going to route in the X-axis motor wire. Then we're just going to close some links in order to keep it in place. And attach it onto the end link. Close that last clip. And then we can keep working our way around. And I'm just going to loop this back inside. And before I put on the last clip, I'm going to attach it to the end link. And it's just needing a little bit of a wiggle here because it doesn't quite want to go in. There we go. And then I close that last clip. And then we just take these wires and we bring them out the side. If you haven't labeled them by now, it's still very easy to tell which is which. The much shorter one will be for the Z, and the longer one will be for the X. One thing I also didn't mention is if you are doing the mirrored version, then all of this drag chain installation will happen the same way but flipped. So just remember to keep that in mind. So the last thing to do before we've got wiring all set up is just clipping these wires in from the back side and running them around the side of the machine and up to the front again. So I'm just going to do that real quick, and I'll see you at the next step.